Hello, good day. Let's take a look at this question. Find the derivative of f of x is equal to a times s raised to the power of n from first principle. Here, the formula for first principle is f prime of x is equal to limit as delta x tend to 0, f uh, open bracket x plus delta s close bracket minus f of x divide delta x, where delta x simply means a small change or an increment. Here we're going to find a way, to find an expression for f of x plus delta x, which is this part of the expression here. So here, uh, f of x plus delta x is simply in is simply this, but in place of s, we will replace it with x plus delta x. That is the basis for first principle. Whenever s occur, we replace it with s plus the small change. Okay, so here we're going to find an appropriate method to do this expansion. Here we adopt we use by using binomial theorem. Recall that in any expansion of a term to the power of any number, whether n, the first expression here, which is x, must have a coefficient of 1. It depends. Okay, then the highest power there is always the given n. So here we see that n is 2, so that s is s raised to power 2. Similarly, the highest power of delta s must also be 2 in this expression. You can see that for s plus delta s raised to the power of 3. Okay, now let's look at the case of x plus delta x raised to the power of n. It will become n combination 0, s raised to power n plus n combination 1, s raised to power n minus 1 delta x. You can see clearly from this expression that the value of delta s is increasing to the right, while of x is decreasing to the left. So you can see that delta s is square, s delta s, then delta s square, to the right, but to the left, you will see that x is eventually decreasing. Okay, that is just the procedure. Now, let's use this binomial expansion to evaluate or to expand this expression here. Okay, so quickly, if we're looking at the case here, n summation k is equal to 0. Okay, and k is moving from 0 to n. From here, n is equal to n as well. N combination k simply means n factorial divide n minus k factorial times k factorial. So here, let's quickly move on. When k is equal to 0, this expression here will turn out to be s raised to the power of n. So n combination 0, n factorial divide n minus 0 factorial times 0 factorial. But recall that 0 factorial is 1, so that the whole of this expression is equal to 1. So that's the first expansion of when k is 0. Now let's look at k when k is 1. The expression becomes n combination 1 s raised to the power of n minus 1 delta x raised to the power 1. But n combination 1, let's find an expression for n combination 1. So which is n factorial divide n minus 1 factorial times 1 factorial. Here we need to look at, because of the fact that we're having n factorial at the denominator here, we need to find an expression for n factorial, which can also be the expansion of n factorial is n into n minus 1 factorial. Okay, because of the fact that we're having n minus 1 factorial at the denominator. So the numerator, which is n factorial, we can also find an expression for it. Okay, so that n factorial and n factorial, they will be off. So that for k is equals to 2, we have a n. So this become n times s raised to power n minus delta x. That is when k is 1. Let's look at k is 2. Our expression become n combination 2 s raised to power n minus 2 delta x squared. For n combination 2 can also be expressed as this because of the fact that we add n minus 2 factorial at the denominator. We also expand n factorial at the numerator to adjust some simplification there. So the expression become this n into n minus 1 into n minus 2 factorial, so that n minus 2 factorial will go off with n minus 2 factorial, and this become n minus n into n minus 1 divide 2 factorial. Okay, so the expression for when k is equal to 2 is equal to this, equals to n into n minus 1 over 2 factorial s raised to power n minus 2 delta s squared. Now let's move on quickly. For n is equals when k is equals to 3, the expression become n combination 3 s raised to power 3 s raised to power n minus 3 delta s raised to power 3. But let's find an expression for n combination 3, okay, which is n factorial into n minus 3 factorial times 3 factorial. But we still need to accommodate, make an expression so that we can simplify n minus 3 factorial at the denominator. So n factorial can as well be expressed as n into n minus 1 into n minus 2 into n minus 3 or factorial, so that n minus 3 factorial will cancel n minus 3 factorial, and the expression become n into n minus 1 into n minus 2 over 3 factorial, and s raised to power n minus 3 delta x raised to the power of 3. Okay, now this will continue till we get to n, but to avoid time wastage, we just look for this expression here, which is plus plus plus, till we look for when n is equal to n. That means when n is equal to k, or when k is equal to n, the whole expression here will be s raised to power n minus n into delta x raised to power n, then n combination n, which is the same thing as 1. Okay, so that everything here will become delta n. Okay, quickly, everything there will become delta raised to the power of n, delta x raised to the power of n. Okay, so if this thing, this expression now, because we said it is multiplied by a, so the a will multiply all the 10 that we have evaluated since, and it will become a into the whole of this expression. By the time a multiplied, become ax n plus a n x a n s raised to power n minus 1 delta s plus a into x a into n minus n minus 1 all over 2 factorial, then s raised to power n minus 2 delta s square of times or plus a times n into n minus 1 into n minus 2 over 3 factorial times s raised to power n minus 3 delta s cube plus dash plus a times delta s raised to power n. Like I said, that the highest power of delta s is n, and that of s is also n. So here, let's look at f of x plus delta s minus f of x. So here, this is f of s plus delta s, which is this expression, minus f of x, which is f of s, which is which is this. By the time we subtract this from this, this will be off, and we'll be left with just this portion. Be left with just this part. Okay, so here f of x plus delta x minus f of x is equal to this. Okay, now next thing is, remember that our function here, the first derivative, we must divide it by delta x. So here uh, everything is divided by as limit delta s tend to 0 divided by delta x. Okay, each of these limit here, the limit will affect, and this division sign, this delta s will divide each of these limit, and this become, okay, limit delta s tend to 0 a n s raised by n minus 1 delta x divide delta x. You see that delta s will divide delta x there. Similarly here, delta s will divide delta x here, s square here. We left with 1 delta s, which is this expression now. Okay. Similarly, this delta x will divide delta x cube here. That's why we obtain delta s square in this aspect. As the limit applied to this become a delta x raised by n divide delta x. Okay, here you see that the only one that is not having delta x is a n s raised by n minus delta n. The other one, once this limit tend to 0, the whole of this part is eventually blown off, and f of s prime becomes a times n times s raised to the power of n minus 1. Okay, this is the derivative of f of x a times s raised to the power of n from first principle. Please, if you like this video, please help me share this video, help me subscribe to my YouTube channel, help me grow it. Have a nice time. See you in my next virtual class.